Hola, mi clase. All right, we're doing 8.2. We're still solving systems, but I'm going to teach you how to solve them by substitution. So your key terms is the steps on how to solve for substitution. So a substitution method is used to solve systems of linear equations by solving an equation for one variable and then substituting, so clearly substitution, the resulting expression for that variable in the other equation. The steps for this method are as follows. Step one, solve one of the equations for one of its variables. So we don't have to solve for y anymore. If I want, I could solve for x. It doesn't matter which one. Okay, x or y. We're going to substitute the expression from step one into the other equation and solve for the other variable. So if we solve for y, in step two, we solve for x. Okay? And then step three, we take our answer from step two and we substitute it again into the original equation from step one and then solve for the original variable that we solve for. Okay, so I know that sounds really confusing when I first read it, but it's solve, substitute, solve, substitute, solve is kind of the steps. I know this is a graph, it's just so that we can check. We're going to kind of check our answer on this graph, okay? So we have these two equations. It says negative 3x plus y equals 1 and 4x plus y equals 8. We're going to pick one of these equations and solve for one of its variables. You want to solve for a coefficient of 1 or negative 1. Start with 1 and then go with negative 1 if you don't have 1. So if we look here, the coefficient of this is negative 3. The coefficient of this one is 1. Remember how there's an imaginary 1 right here? Coefficient of here, x, is 4, and the coefficient of this y is 1. So we can actually solve for either one of these y's, this one or this one. I'm going to solve this one. We're going to call this equation 1, and we'll call this equation 2, okay? So I'm going to take that first equation, negative 3, this is step 1, x plus y equals 1. And what I'm going to do is I'm going to solve for y. So I'm going to add 3x to both sides, just like we did when we had to solve this for slope-intercept form. This cancels, and we get y equals 3x plus 1. Okay, step 1 is done. Okay, now step 2 is I take this expression, and I'm going to plug it in to my other equation. See my other equation? 4x plus y equals 8. I'm going to put that right here. That's because it says y equals 3x plus 1. So anytime there's a y, I'm now going to make it 3x plus 1. It's going to look like this. 4x plus, I'm going to use a different color so you can see it, 3x plus 1. And then I'm going to set it equal to 8 still. I didn't change the equation. It's like what I did is I took a dollar, right? Pretend my y is $1, and I made it into 4 quarters. 4 quarters is still $1. It's just in a different form. So when I say y equals 3x plus 1, it's the same thing as saying 4 quarters is $1. Now that I've substituted, I'm going to combine like terms and solve for x. So 4x plus 3x is 7x, and then plus 1 equals 8. I now solve this like a one-step equation, two-step equation, minus 1, cancel here, 7x equals 7. We will divide by 7, and it says that x equals 1. Now, so I did step 1, I did step 2. What I'm going to do now is step 3, okay? I have to take this, and remember my original equation, this very first one from step 1, negative 3x plus y equals 1. I'm going to take that x and put it there, because x equals 1. So I'm going to change all my x's to 1. So it would look like this. Negative 3 Again, I'm going to change the color so it matches the color from over there. Substitute in my 1 plus y equals 1. So negative 3 times 1 is negative 3 plus y equals 1. I add 3 to both sides, and we get y equals 4. Oop, sorry about that. So I have x, 1, I have y, 4. My solution, okay, let me pick another color. The solution is 1, 4. Because that's my x and that's my y. Whoa! There we go. I don't even know how I did that. All right, so what we're going to do is use the graph to check it. So my solution is at 1, 4. 1, 4. This is where I want my graphs to cross. Okay? Now, I already solved 1 for slope-intercept 4. Okay, so I'm going to graph it right now just to check that I did okay. So y equals 3x plus 1. So I'm going to go to plus 1. Then I count 1, 2, 3, 1. Oh, well, that's good. It definitely crosses my point. I'm actually just going to be done because it proves me that it works for this equation. Okay? Now, for my other equation, I do need to solve it. I'm going to go minus 4x. I'm going to do it right here. Minus 4x. Oops. I'm going to get y equals negative 4x plus 8. And unfortunately, it doesn't fit on my grid, but we're going to do the best we can. So this is 6. And let's say 7, 8. Close enough, right? We're going to go down 4, right 1. So 7, so 1, 2, 3, 4, 1. And look at that. It is, in fact, where my graphs intersect. So we're good. We did do it right. If our graphs had not crossed here, then this wouldn't be my solution. But you can see from the check that both lines did, in fact, go through there. So we're good. There's our answer. All right, let's practice another one. So I'm going to do the same way, step 1, 2, 3, 4, okay? So coefficient here is 1. Coefficient on this y is negative 4. Coefficient on this x is 2. And the coefficient on this y is negative 3. So remember on the first example, I said we always want to solve for the coefficient of 1. Well, the only one that has a coefficient of 1 is x. So here's what it's going to look like. This is step 1. X minus 4y, I take my original equation, and I'm going to solve for x. I want to get x to hang out by itself. Okay? So we're going to add 4y. Negative 4y, positive 4y, gone. Plus 4y. So we get x equals 4y plus 4. So step 1's done. Step 2. So I'm going to take now my second equation, right? This was 1, this was 2. I'm going to take my second equation, 2x minus 3y equals negative 3. I have to take this, and now I'm going to put it where x is, because that's what x equals. So here's what it looks like. 2 parentheses 4y plus 4 minus 3y equals negative 3. So we distribute first. We get 8y plus 8 minus 3y equals negative 3. 8y minus 3y is 5y plus 8 equals negative 3. I'm going to subtract 8. I get 5y equals negative 3 and negative 8, 8, 7, 6, 5. No, 8, 9, 10, 11. Negative 11 over, and then I'm going to divide by 5. I'm going to get y equals negative 11 over 5. All right, step 3. I go back to my original equation, x minus 4y equals 4. And now we're going to take this and put it in for y. Okay, so x minus 4, I'm going to put it over 1. And the reason I'm doing that is because I have a fraction. Negative 11 over 5 equals 4. Let me change my color back. So multiply crossed. I'm going to come over here, x minus, plus negative times a negative is a positive. 44 over 5 equals 4. I subtract 44 over 5. All right, so we're going to have to find a common denominator. It would just be 5. So it would be 20 over 5 minus 44 over 5. Remember, you are allowed to have calculators still at this point. So you can just take your calculator if you're worried about that and do 20 minus 44. And so our final answer for x, lost my pen, x is going to equal negative 24 over 5. So now that we have our two numbers, x and y, our solution would be negative 24 fifths, comma, negative 11 fifths. That's not very fun to graph, is it? Negative 24 over 5 is approximately negative 4 and 8 tenths. So it's super, super close to being 5. So 1, 2, 3, 4. So it's like way over here. And then 11 over 5 is about 2 and 2 tenths. So the point that we're looking for is right around, can't get it to draw, right around here. So not very fun to graph. That's my solution right there. All right, so technically I do want us to check this on the graph. So I'm going to take, let's solve this one first since it's right here. I'm going to go minus 2x, minus 2x. I'm going to go negative 3y equals negative 2x minus 3. We're going to divide by negative 3, right? Everything, it's going to look like this. And we'll get y equals negative over negative is positive, so 2/3 x. And then negative 3 divided by negative 3 would be positive 1. So we start at positive 1. I'm going to make this one red. Technically, I should have made it red in the first place. So go to positive 1. Now, if I go 1, 2, 1, 2, 3, you notice I'm just getting further away from my point, which isn't helpful. So I'm going to go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then if you look, my graph's the dot's a little big, but if you notice, if I hadn't made that dot so big or a little more accurate, it would have actually gone through the exact point I'm looking for. So that's good. So let's take our other equation, x minus 4y equals 4. We're going to subtract x. Negative 4y equals negative x plus 4. We're going to divide by negative 4. And we're going to get y equals, a negative over a negative is positive. Remember, there's an imaginary 1 right here, so this is 1/4 x. And then a positive over a negative is a negative, and 4 over 4 is 1. So we go to negative 1. Again, if I go 1, 2, 3, 1, 2, 3, 4, right? That's not very helpful. But if I go 1, 1, 2, 3, 4, 1, 1, 2, 3, 4-ish, you can see again, it's gonna be super, super, super close. Again, that dot that I graphed wasn't perfect, but you can see they intersect right here, and they clearly intersect very, very, very close to these points. So we did good, okay? You can see graphing that and finding that is very difficult, so that's why solving it by substitution is the way to go. You would have had to estimate that, which isn't always the best option when we can get an exact answer of negative 24 over 5 and negative 11 over 5. Okay, so fractions can exist when it comes to systems as well. All right, so we're going to solve these. Now, I want to show you this time that it doesn't matter for this equation. I'm going to do step 1. So remember on the first example I did this one. I'm going to now solve for this one, and I'm doing that just to show you it doesn't matter. I don't have to use equation 1 and equation 2. I don't have to do that. I can solve for any variable I want to. So I'm going to go negative 2x plus y equals 1, and I'm going to solve for this variable. So I'm going to go plus 2x plus 2x, and we're going to get y equals 2x plus 1. Now step 2, we're going to go the other equation, so 3x plus y equals 11. Again, we're going to take this and put it right here, because that's what y is. So 3x plus, substitute, 2x plus 1 equals 11. 5x plus 1 equals 11, minus 1. 5x equals 10. Divide by 5, and we get x equals 2. All right. Step 3, go back to this original equation, negative 2x plus y equals 1, and now x becomes 2. So negative 2, plug in 2, I got that from right here, plus y equals 1. Negative 2 times 2 is negative 4 plus y equals 1. Add 4, y equals 5. So my solution is 2, 5. All right. Let's do this one. Step 1, I'm going to solve for the x. So x plus 6y equals 18. So I'm going to go minus 6y, tuck that in there. Oh, not equal to. Minus 6y, I get x equals negative 6y plus 18. So step 2, 2x minus 3y equals negative 24. So now x becomes this, so 2 parentheses, negative 6y plus 18 minus 3y equals negative 24. Distribute negative 12y plus 18, nope, not 18, 36. Sorry about that, 36 minus 3y equals negative 24. Negative 12y, take away 3 more y's, would actually be negative 15 y's plus 36 equals negative 24. I'm going to subtract 36. I'm going to get negative 15y, forgot my 1, equals, these are both negatives, so it's going to be a bigger negative. That's 10 and then 3, 4, 5, 6. We'll divide by negative 15, and I get y equals actually positive 4. Negative over negative, and 15 into 60 is 4. All right, last step. I go back to this original equation, x plus 6y equals 18. We get x plus 6 parentheses 4 equals 18. I'm getting the 4 from right here. See, y equals 4. X plus 24 equals 18 minus 24. And x will equal, I want to try to do that in my head, negative 6. So our solution would be negative 6, comma, 4, close those parentheses. All right, so here's your independent practice. I'll give you a hint. Solve for this x. Okay, step 1, solve for that x. All right, until next time, adios.